Hi, this is Gaurav here. This is the last video of this particular series, Branch Node Management. Uh, this is video number 1.6, and in this video, I'll be covering heating loops, boiler, or also known as boiler loops, and sizing objects, thermostat objects, zone infiltration objects, and outdoor air specific design specification objects. Uh, Heating loops was the major part which was left. I intentionally left it for the end because it's very long work and it's very repetitive. Also, this is exactly similar to the work we did in the beginning, so it made no sense doing it again. I'll be just showing you the diagrams. I have actually made the nodes and make the arrangement. I'll also show you the nodes for you to view after doing it on your own. So what I decided was to take 10 reheat coils and getting hot water from purchased heating. That would be the system one. Another system would be to take hot water from the boiler and giving it to AHU, three AHU heating coils. So we'll be making two heating systems. This is a line diagram, energy plus line HVAC diagram for the two heating systems. Um, in this figure, I have marked the nodes. I have done this part, uh, and you can check it after doing it. This is for heating system 2. I'll be putting these two images in the description as it may not be too much visible. After making these, the only thing left would be to define heating loops in plant loop object and making operation scheme similarly as done in chilled water loops. So you have to make plant equipment list first, then operation heating load, then operation schemes. After that, the set point managers schedule would be left. There would be total four set point managers. Okay, after this, the major part left is just completing the IDF file, making the remaining objects. The very first is making zone infiltration. Zone infiltration design flow rate is actually used to make used to it is used to tell the energy plus about the small leakages inside a zone. Like it can be small leakages in windows, it can be below our doors, above our doors, small holes inside walls. It can be anything in infiltrating inside. So uh, we will just here there is an option to put this zone infiltration to all zones. We can make a zone list. So above here I have made a zone list, all zones. So we'll just make one object. This would we'll call infiltration. We'll connect it to all zones here, and schedule will be infiltration schedule. I'll show you the schedule after making this. This will put at flow per zone. This can be flow per zone, flow per area, flow per exterior area, air changes per hour. So right now we'll just put it flow per zone. We'll put it as 0.0855, and these coefficients, we'll put this as 0, and this as 0.2237, and this would be 0. The other thing remaining is design specification outdoor air. You can read about this in detail in IO reference. Here also we can just make one object. We'll make it as DSO, design specification outdoor. We'll keep these same values. After this, the left is sizing parameters. This would be 1.3 and 1.3. The sizing zone, here we can apply it to all zone in one go. This has to be 14. I've also told before, you can see about these particular objects in IO reference. Um, you can read clearly there. Here we have to mark design specification outdoor here. So it was not required to make it for all zones. We The one was okay. The next is sizing systems. Uh, this we have to make for three air loops. Um, so this would be zero point 0.3 and 7, 0.008. The last thing and the most important is sizing plant. This we have to make it for um, one cooling chill water plant, one condenser plant, and for two heating coil, for two heating systems. So for heating system one, this would be for heating, and the temperature would be 82. This is actually the temperature of the water which is coming out of the loop. 82 degrees would be the temperature, and the same would be for another. We'll make one for cooling coil. For chilled water loop, this will be cooling, and this would be 6.677, 6.67, and this would be 5. The left is condenser loop. Condenser water is not so warm and not so cold. It is 29.4 and 5.6 here. Okay, we are done with almost everything. The only thing remaining is thermostat. Thermostat, there are many kind of thermostat. We'll be using dual set point. We'll just name it dual set point, and heating set point would be, and cooling set point will be cooling set point. I'll show you these two schedules after this. And zone control would be zone control. This will apply it for the all zones, and this schedule actually tells what kind of thermostat we are using. You can see in the field description. Um, to use thermostat dual point, we have to put 4 in the schedule. So this uh, dual zone control type schedule actually contains 4 for all over the year. So this would be a dual set point, and the object would be dual SP. So by making the thermostat, I think we are done with everything in our IDF file. We have made all the air loops, all the plant loops, uh, all the thermostat settings. So in the next video, tell you about the common errors and common CV errors and warnings which come in our simulation, especially during making branches and loops, and how do you rectify them. And I'll also tell you some tips by how seeing nodes we can correct our model. So this would be the end of this video. Next video would be just a small video on simulations, running simulation and rectifying the errors, and few tips. Thank you.